Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve question number 55 of GATE 2022 statistics paper. The problem says that there are 5 observations 0, 1, 1, 2, 0 of a random variable x which follows a Poisson distribution with parameter theta greater than 0. The minimum the minimum variance unbiased estimator of probability of x less than equal to 1 based on this data be alpha. So we have to find 5 to the power 4 into alpha in integer. So to start the problem, let us consider all the facts that is given. That is, xi follows iid Poisson theta for theta greater than 0 and I equal to 1 to n for n equal to 5. To find the minimum variance unbiased estimator of probability x less than equal to 1, which is basically probability of x equal to 0 plus probability x equal to 1, let us find the minimum variance unbiased estimator of probability of x equal to k, for k belongs to natural number union 0, which is the support of the Poisson distribution. So consider an estimator hx curl, which is a function of x1, x2, xn given by indicator of x1 equal to k. So observe that here expectation of hx is basically probability of x1 x equal to k. That is, hx curl is an unbiased estimator of probability x equal to k. Okay. So now the family, since Poisson theta greater than 0 belongs to OPF, one parameter exponential family, and hence we know that t equal to summation xi for I equal to 1 to n is complete and sufficient statistics for the family. So by Levens-Cephet theorem, expectation of hx given t is the uniform minimum variance unbiased estimator of probability of x equal to k, that is probability of xn equal to k. So what Levens-Cephet theorem tells us that the basic idea is, say h is an estimator of a parametric function, say beta theta. Okay, so h given t will be the UMBV of beta theta if because we have what t is an unbiased estimator. Okay, t is complete and sufficient. So this basically tells us the Levens-Cephet theorem. So expectation of ht will be expectation of h, which is beta theta. So this is basically unbiased, and this will be minimum variance by the Levens-Cephet theorem. Since t is incomplete sufficient, h given t will be independent of theta, and hence we can prove that it will be minimum variance unbiased estimator. You can try yourself if not known. Okay, so let us focus on the problem. So we have to find expectation of hx given t. So to find that, we find expectation of hx given t equal to t, which is probability of x1 equal to k given summation x equal to t, for k lies between 0 to t. So if we break the probability, that is by definition, it counts probability of x1 equal to k intersection summation xi equal to 1 to 2 equal to t minus k, because x1 equal to k already considered here, and this becomes the denominator. Okay, so now x1 and x2 x1 and x2 up to xn are independent, hence we can multiply the probability here, because probability of x1 equal to a, x2 equal to b equal to probability of x1 equal to a into probability of x2 equal to b. For discrete random variables a, here we consider with a lot of loss of generality if x1 x2 are independent. So by this property, we can write this. And now since probability of x1 equal to k given by this expression from Poisson theta distribution, we get this. And summation xi also follows Poisson n theta. You can prove that is I equal to 1 to n. Summation xi is follows Poisson n theta. So here summation 2 to n, that this is simply follow n minus 1 Poisson n minus 1 into theta. Okay, so by simplifying, we get the statistic t choose k into 1 by n to the power k into 1 minus 1 by n whole to the power t minus k. So basically expectation of hx given t is capital T choose k into 1 by n whole to the power k into 1 minus 1 by n whole to the power t minus k, which is the UMV of p equal to probability of x equal to k by Levens-Cephet theorem. Now probability of x less than equal to 1 is probability of x equal to 0 plus probability x equal to 1 by the additive property of unbiased estimator. We get this. This will be, since expectation of this will be, sorry, let us more say more bit clear. Let me a bit clear. So expectation of this thing will be probability of x equal to 0. Okay. And expectation of the second part will be probability of x equal to 1. So as a whole, expectation is additive, that is expectation of x1 plus x2 equal to expectation of x1 plus expectation of x2, if the expectation exists and all. So this becomes probability of x equal to 0 plus probability of x equal to 1. So this will be probability of x less than equal to 1. So we proved that this is an unbiased estimator. Now to prove this is the minimum variance, this has the minimum variance, we can simply use the Riemann-Schaffer theorem. That is, this is a function of t, which is a complete and sufficient statistic. So unbiased estimator based on complete and sufficient statistics is the UMPV. So Riemann-Schaffer theorem gives us this. So we get 1 minus 1 by n whole to the power t plus t by n into 1 minus 1 by n whole to the power t minus 1 is the UMV of probability of x less than equal to 1. So putting all the values, n equal to 5, capital T equal to summation xi, that is 0 plus 1 plus 1 plus 2 plus 0 equal to 4. Put the values here and we get alpha equal to 4 to the power 4 plus basically 2 into 4 to the power 4 by 5 to the power 4. So 5 to the power 4 into alpha will be 2 into 4 to the power 4, which is 512. So in integer, the value is 512. Okay. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.